So, hello again. In this second part, we're going to solve some trigonometric equations and inequalities. But before doing that, I will report a table here where I can write some of the fundamental results of some angles. So I'm preparing this table that will be useful during the exercises. Okay, here I will report some angles. For each angle, I will report the result of these functions. And we will use these results during the exercises. Okay. Exercise 1. We have to solve this equation. Sine of x equals to 1/2. Let's recall here the unit circle. And I will recall you that the sine of alpha is this segment. So I'm saying that I want to find the angle which gets us 1/2 as sine. Is it sine? But as you can see, this segment is given also by this point, and this angle is pi minus alpha. So if we come back at the table I wrote before, sine of alpha is equal to 1/2 when the angle is pi over 6. So x is equal to pi over 6. But I have to consider also this other point. So this is one solution, but I have also this other solution, that is x minus x, this pi minus pi over 6. And this is equal to 5 pi over 6. Now, we have to recall that the sine is periodic. And the period is 2 pi. So I have to consider also this multiplicity. From the first solution, I can write x is equal pi over 6 plus its multiplicity. So 2, I write here a parameter k, and this k belongs to z. Same thing for the second solution, and this gets me this solution with k always belongs to z. Okay, this is the first exercise. So let's do something similar with the cosine. So exercise 2, we have cosine of x equals to 1/2 again. I will recall here the unit circle, and again I have to find the angle that provides me a cosine of 1/2. So I can consider this point that gives me this cosine, but also this other point here, P prime. And this point is given, if this is alpha, this is minus alpha. So let's go again. Let's look in the table, and the cosine of alpha is equal to 1/2, 1/2, when the angle is pi/3, 60 degrees. I'm going to write here for the second solution, this one, I have to write 0, that is this angle, when I have this point here, 0 minus pi/3. So I'm saying this solution. As before, I have to consider the multiplicity, because also the cosine is a periodic function, and the period is 2 pi again. So I can write here. Before doing that, I can group these two solutions in only one, because this is pi/3 and this is minus pi/3, so I can write plus minus pi/3, and I can write here 2k pi, with k belongs to z. Okay. Let's move on. Exercise 3. I have this equation, sine of x equals 2. Now, you can recall that the sine of alpha has values between -1 and 1, with alpha belonging to R. So this equation has not solution in R. It's impossible. Let's move on. Let's consider this equation. Okay, we can do just some basic math to write it like this one. again cosine of x is equal to the square root of 3 over 2. And if we look in the table, we can see that the cosine of alpha is equal to square root of 3 over 2 if the angle is equal to 30 degrees or pi over 6. So I'm going to write it here. X is equal to plus minus pi over 6 plus 2 times k pi, k belonging to z. From now on, I won't write this thing because it's always like that. Okay, let's move on the next exercise. The next one is cotangent of pi over 4 minus 3 times x equals to square root of 3. Now, we can solve this equation with a little trick. If we're going to see in the table, square root of 3 is given considering, again, an angle of pi over 6. So I can write it as the cotangent. Let's write it here. This is also equal to the cotangent of pi over 6. And this is true because of this one. This one. Now I can write this thing, so I can compare the arguments of the two functions, but I have to consider also the multiplicity of the cotangent. So let's write it here. Plus k pi, because I recall you that the cotangent is periodic with period k, period pi. So I can do some math here. Pi over 4 minus pi over 6 plus k pi is equal to 3 times x. I'm going to write it here. So from this one, I can compute it, some mass here. And from this one, I can get that 3 times x equals to pi over 12 plus k pi. Last step, I can divide all by 3. So x is equal to pi over 36 plus k pi over 3. And this is the result of this equation. Okay, let's go on. Exercise 6. I have another equation. So 2 times cosine 2 times x plus pi over 6 minus 1 is equal to 0. As before, I can do some basic math. So 2 cosine, I can bring the 1 to the second member. Here I can divide by 2. So I have that cosine 2x plus pi over 6 is equal to 1/2. As before, I'm going to look in the table when the cosine is 1/2. So I can see here the cosine is 1/2 when the angle is 60 degrees, so pi over 3. And I'm going to write it here, so cosine of pi over 3. As before, I can compare the arguments of the cosine, so I can write 2 times x plus pi over 6, and I add the multiplicity here, so 2k pi is equal to pi over 3. But I have to consider also, let's recall here, I'm considering this point, I have to consider also this other point. So this is one solution. The other one is 2x plus pi over 6 plus 2k pi is equal to minus pi over 3. That is, if this is alpha, this is minus alpha. This is alpha, and this is minus alpha. Okay, from this one, I can go on and solve the equation considering the two solutions. From this one, I can write 2x is equal to pi over 3 minus pi over 6 minus 2k pi. Again, just some basic math. And I can get the result considering this other solution. Okay, just let's finish this one. So x is equal to pi over 12 plus k pi. And this is the solution obtained by the first one. Let's continue with this other one. So 2x is equal to these quantities. I can solve here by doing this. And again, from this one I can get x is equal to minus pi over 4 plus k pi. And this is the solution of the second one. Now, I can go on and consider Okay, here I consider this minus sign, this one and this one, inside k, inside this parameter k. So this minus is inside k, and I can write plus here and here. Okay, so this is one solution, and this is the other one. Let's go on with another exercise. Exercise 7. Okay, I have a second order equation in cosine, so 2 cosine squared of x minus 5 times cosine of x plus 2 equals to 0. Okay, so this is a second order equation. If I place cosine of x as a variable that I call t, I can write this equation as 2t squared minus 5t plus 2 equals 0. And now I can solve this equation as a normal second order equation. So I can write t1, 2 equals 2. I have this kind of equation. And t1, 2 is given by minus p plus minus b squared minus 4ac divided by 2a. Okay, so applying this formula to this case, I can write 5 plus minus the square root of b squared is 25. If I do the multiplication here, I can get 16 over 2 times 2, so 4. I can write here the result. This is 9, so the square root of 9 is 3. And from this one, I get that t1 is 1/2 and t2 is equal to. But I have not finished yet, because t is equal to cosine of x. I did this substitution here. So I have to replace t with the cosine of x. So cosine of x is equal 1/2, and cosine of x is equal to 2 from this one. Now I can say that this one is impossible considering x belonging to R, so this has no solutions. And this one, let's look in the table. Cosine is equal to 1/2 when the angle is 60 degrees, so pi over 3. Considering its multiplicity and the other point in the unit circle, we can say that x is equal to plus minus pi over 3 plus 2k pi. And this is the solution of the equation. Okay, let's go on. exercise 8. Two tangent of x plus square root of 3 all to the power of 2 is equal to 3. Okay, so now I can compute this squared term, so I can write 4 tangent square of x plus 4 square root of 3 tangent of x plus 3 is equal to 3. I recall you here that a plus b to the power of 2 is equal to a squared plus 2 times ab plus b squared. And that's what I did here. From this one I can simplify these quantities and I can get 4 tangent square of x plus 4 again I can write it that tangent of x is equal to a variable t that I call t, and from this one I can write that t, okay, let's write it, t squared plus square root of 3 times t equals 0. The 4 here is simplified. So from this one I can group it by t. If I group it by t, I can get t times t plus square root of 3 is equal to 0. From this one I can get that t1 is equal to 0 and t2 is equal to minus square root of 3. As before, I have not finished yet because I have to replace the substitution I did before. So t is equal to tangent of x. So from the first one I can get tangent of x is equal to 0, and from the second one tangent of x is equal to minus square root of 3. Now from this one let's look up in the table, and the tangent of alpha is equal to 0 when the angle is 0. So I can write it as x is equal to 0, and I have to consider also its multiplicity. So 0 plus k pi, and this is equal to simply k pi. K pi because the tangent is periodic of period pi. Let's do the same for the second solution, and let's hear that the tangent of alpha is equal to square root of 3 when the angle is equal to pi over 3, 60 degrees. But here I have a minus sign, so I have to consider the opposite angle. So here I can write that x is equal to pi minus pi over 3, always with its multiplicity. From this one I can write it as 2 pi over 3 plus k pi. And I have here the two solutions. So this is the first one, and this is the second one. Okay, let's go on. Exercise 9. Another equation, 1 minus 2 times cosine squared of x plus sine of x equals 0. Now I can recall that the cosine squared, but before doing that I can write sine squared of x plus cosine squared of x is equal to 1, and this is the fundamental equation of trigonometry. So I can write the cosine squared as 1 minus sine squared of x. I can write that equation in here. So 1 minus 2 times that 1 minus sine squared of x plus sine of x is equal to 0. I can do the product here. I can write here 1 minus 2 as minus 1. And as before, I do a substitution considering the sine of x a variable t. So I can write this equation as 2t squared plus t minus 1 equals 0. Minus 1 minus 2t squared plus t equals 0, and I wrote it like this. This is again a second order equation that can be solved like this. So t1, 2 is equal to minus 1 plus minus 1 squared plus the product a times c. 4 times 8, 5 times c. So 8 over 2a. From this one, I can write this. Again, here I have 9. The square root of 9 is equal to 3, and I get this result. Okay. From this one I get, so t1 is equal to minus 1, and t2 is equal to 1 half. Now I recall you that t is equal to sine of x, so I can write here sine of x is equal to minus 1, and sine of x is equal to 1 half. Let's look again in the table, but sine of alpha is equal to -1 when the angle is 270 degrees. I can write it also as, this angle can be written also as minus pi over 2. So from this one I can write x equal to minus pi over 2 plus 2k pi. Okay, minus pi 2 is the same angle of this one. It's the same angle written in two different ways. The second solution, the sine of x is equal to 1/2. Let's look in the table. So I can see when the angle is 30 degrees, so pi over 6. And I write it, x is equal to but there I have not finished yet, because I have to consider also, let's recall it here, the sine of p is equal also to the sine of p prime. So I have to consider also x as 5 over 6 pi. So here I have the solutions of the equation. Okay, let's move on. Exercise 10. I have cotangent of x plus cosine of x equals 0. Now I can write the cotangent. I recall you that the cotangent of x is equal to cosine of x over the sine of x. So I can write the cotangent like that. So cosine of x over sine of x plus cosine of x equals 0. Now, before moving on, I have to make a consideration. I have a division by sine of x, but I can do this division if and only if the sine of x is not equal to 0. And this is true when x is not equal to k pi. So this is the condition for the solutions of this equation. Now I can go on, and then I can write this equation like this: cosine of x plus sine of x cosine of x equals 0. I simply multiplied the sine of x in each member. Now I can group this equation by cosine of x, and I can get 1 plus sine of x equals 0. From this one, I get that cosine of x is equal to 0, and 1 plus sine of x is equal to 0. So let's look in the table, but it's quite obvious. The cosine of alpha is equal to 0 when the angle is 90 degrees. So x is equal to pi over 2, but I have to consider also the other angle and the multiplicity. From the first one. From the second one, well, I can write sine of x equals to minus 1, and it's simple, so x is equal to minus 5 over 2 plus 2k pi. Again, here I can group the two solutions in one compact way, so x is equal to pi over 2 plus k pi. Okay? Let's move on. Exercise 11. I have this equation, sine of x plus square root of 3 cosine of x equals 0. Okay, so to solve this equation, I can use these formulas. I can write them here. Sine of x is equal to 2 tangent of x over 2 all divided by 1 tangent square of x over 2. And the cosine of x is 1 minus tangent square of x over 2 divided by 1 plus tangent square of x over 2. These are fundamentals formulas that can be used to solve the equation. But as you can see, we are switching from sine and cosine functions in tangent functions. And I will recall you that the tangent of alpha has asymptotes in alpha equals pi over 2. So, before using this formula, I have to check if the argument of the tangent is solution of the equation. And in this case, I have to check if pi over 2 divided by 2 is solution. So simply is if pi plus k pi is solution to k pi, sorry. And how can I do this? Simply substituting pi to the equation. So sine of pi plus square root of 3 cosine of pi equals 0. I have to check if this equation is satisfied. So sine of pi is 0. Cosine of pi is 1. So 0 plus square root of 3 equals 0. Well, this is not true. So x is not equal to pi plus 2k pi. Once verified this solution, I can use these formulas to solve the equation. So I will report this result here. And I'm using this formula I just wrote. Okay, just imposing t is equal to the tangent of x over 2, I can rewrite the equation using that formula with 2t I just used the formula I wrote before and replaced the sine and cosine functions with the tangent. From that, I can rewrite altogether as 2t over 1 plus t squared. Okay, let's write it like that. Okay. From this, now here I can simplify this because this quantity is always greater than 0, so the division is possible. And I can rewrite that as a normal second order, a standard second order equation. Okay. From this one, I get the two solutions, 1, 2, as 2 plus minus the square root of 4 plus 12, all divided by 2 square root of 3. And I get 2 plus minus 4 divided 2 square root of 3. Now, so I got T1 is equal to 2 just by summing the numerator. Okay, so I can erase also this one. Now, let's recall that t is the tangent of x squared and is equal to this quantity. Same thing here. Now, I can write this quantity as, let's write it here, this quantity is equal to minus square root of 3 over 3. Same thing I will do here. So and this is simply square root of 3. I get this just by doing times 2 square root of 3 to square root of 3 and go on with the computation. I got this one. Okay, so once I got here and so on, I can solve I'm approaching to solve the equation. So let's look in the table. Square root of 3 over 3, the tangent is equal to pi over 6. So I can write that x over 2 is equal to, I have the minus sign and the multiplicity. Let's do the same for the other solution. So if I look in the table, square root of 3 when the angle is pi over 3. So okay, from here I am almost finished. So just rewriting it as again, I can write it this solution considering x equal to so I group the solutions. Let's go on. Exercise 12. Okay, so when I have this kind of equation, I can do this little trick. I can divide it all by cosine squared of x. Why I did this? Because in this way I get an equation in the form of tangent square of x plus tangent of x equals 0. So I replace the two functions sine and cosine with one single function in tangent, and I can solve it considering again t equals to tangent of x. So this is again a second order equation, a simple second order equation. And from here I get the two solutions, that is t equals 0. The first one is t equals 0, and the second one is t equals to minus 1. Okay. From this one, I can write that tangent of x is equal to 0, and this one is tangent of x equals minus 1. Now, let's go again in the table. So, from the first one, I get that x is equal to 0, again plus k pi, so this is simply k pi. And the second one, well, let's look again in the table. I got 1 here at pi over 4, but here I have minus 1, so x is equal to minus pi over 4 plus k pi. So these two are the solutions of this equation. Okay, so let's do another equation, but this time considering an inverse function. So arc sine of x is equal to pi over 6. How can I solve this equation? Well, I can compute the sine at both members. Here I get simply x is equal to sine of pi over 6. And let's look again in the table. The sine of pi over 6 is 1/2. So the solution of this equation is simply x equal to 1/2. Let's do another one. I can solve this equation as before, so I compute the cosine this time to both members. from here I get simply x over 3. And let's look in the table. The cosine of pi over 6 is square root of 3 over 2. Just some simple math, x is equal to 3 square root of 3 over 2. And this is the solution of this equation. So arcsine of x plus 3 over 4 is equal to pi half. So always the same way, so I compute the sine at both members. Here I get x plus 3 over 4, and the sine of pi 2 over 2 is very simple, and I write it here. So I can get that x is equal to 1, because I multiply by 4 here, and I subtract 3. Let's do another one. Arctangent of 2x plus 1 over x minus 3 is equal to pi fourth. Of course, I computed the tangent on both members, so the tangent of pi over 4 is simply 1. Here I get the argument of the arctangent, and here I get only 1. Okay. Also, this one was quite simple. Let's do one last exercise with the equations before going to inequalities. And this one is a system of equations. So x plus y is equal to pi, and sine of x plus sine of y is equal to 1. I can solve this system by substitution. So from the first one I get pi minus y, and this one, this equation, I'm gonna replace x here. So sine of pi minus y plus sine of y is equal to 1. Here I can write this quantity here in this way. This one, and then Okay. So that's the result, this one. From that, I get 2 sine of y is equal to 1, the second equation. And again, the first one is untouched, so I'm solving just the second one. Now, this one is an equation that we solved before, so I just report here the result. Now, I recall that the previous equation, the first equation, was this one. So, just by computing some simple math, I can obtain the value of x. So, x is pi minus each of these solutions. I'll write them here. Okay, and this one is this one. So this is the solution of the system. Okay, we have done with the equations, trigonometric equations, and now let's move on trigonometrics inequalities. I write here that we're going to solve these inequalities in the range x in 0 to pi. So the first one, this is the exercise 18. The first one is 2 times sine of x minus square root of 3 greater or equal to 0. Now, okay, let's solve it just by doing some calculation. This is quite obvious. And now, let's see, what does it mean, this thing? Let's consider again the unit circle. When I had only the equal sign, I was looking for this segment, okay, this value. Now, I'm saying that the sine of x must be greater or equal to this one. So I'm looking for this part. And now, but the equation wants the angle of this sine function. So I'm looking to this arc on the circle. Okay. So let's look in the table. I have here square root of 3 over 2, and this is the result. But I'm saying that I want So this is pi over 3. This one is pi minus pi over 3. And I want this arc. So I'm saying x must be greater or equal to pi over 3, and x must be less or equal to pi minus pi over 3, and this is equal to so putting all together, x is this one. This is the solution of this inequality. Let's do another one. Okay, 2 cosine of x plus 1 is less than 0. Again, as before, I can write it like this. And let's consider again the unit circle. So I'm looking this time at this arc on the circle. So the point given by the angle that composes the arc. And this is, okay, let's write this point P here, given by the angle what am I doing here? This is the point given by this angle minus the point given by this angle. If I consider this, I consider this one. I do the same thing for the other point. So I can write that x is in so this one is related to this point, and this one is related to this other point. Let's compute here the math. I can simplify this expression as this one. And this is the solution of the inequality. Okay, let's go on. I have another inequality, so okay, now I can do as before with the equation. So I place sine of x equals t, and I compute the inequality as a second order inequality. From this I get that t squared is greater or equal to 1/2, and the solution of this inequality is t less than or equal to 1 over square root of 2 and t2 greater than or equal to 1 over square root of 2. I can replace t with the sine of x. So sine of x, let's write it in a better way. Okay, so from the first one, I have a minus sign here. Square root of 2 over 2 is given by this angle, but if I consider all the opposite angles, I get the solution this is from the first one. From the second one, I get x so this is the solution of the inequality. Okay. Let's do just a couple of exercises. So let's do another one. Okay, again, here I can consider the fundamental equation of trigonometry. So I can write the cosine as in this way. So I did some math here, so I changed the sign here, sum them together, and change the sign here, the inequality sign. Again, I can do this substitution, and I get t squared minus t minus 2 less than or equal to 0. From this one, I consider the associated equation, so t squared minus t minus 2 equals 0. I get t1, 2 Now I consider the solution as the solution of the inequality, so I have t, that is this one, and just by replacing d with the sign, I got this solution. And as you can see, this is satisfied for each x belonging to R, because the sign is always greater than -1 and is always less than 2. So this is the solution of the inequality. Okay, let's do the last two exercises. So, tangent of x divided by 2 cosine of x plus square root of 2. So, before computing this inequality, we have to express the domain of this ratio. So the domain is 2 cosine x plus the denominator of this ratio must be not equal to 0, and I can write it like that. And from this one, I get that x must be not equal to x pi minus pi over 4 and x not equal to pi plus pi over 4. From the first one, I get this one, and from the second one, I get this one. So this is the domain of this ratio. Now I can solve the inequality considering the numerator and the denominator independently. So tangent of x greater or equal to 0, and the denominator okay. I have to erase this. From the numerator, I get that x Okay, and from the denominator, write it here, cosine of x greater than okay, from this one I get that okay, so I get this one and this one. Now, to put all together, I have to draw a graph. So let's save this result. I'm gonna keep this here. Okay, I'm gonna draw a graph where I have the numerator and the denominator here. So let's put here all the solutions. I'm gonna report here what we got before from the domain. So now I'm gonna represent all the solution inside this graph. So from the denominator, I get from the first one this one. And where I have also the equal sign, I draw a point here. When I don't have the equal sign, I place an empty circle. Again, I have the other solution, so from the denominator, I got this one and I have the equal sign here and here, and from this one I get this. Now I'm gonna place a dashed line where I don't have the solution. And I will report also the domain, so x must be not equal to 3 pi over 4, so here I put an empty circle, same thing here. Okay, now I will compute the sine rule, so this is a minus, this is a minus, I got plus. Here I got plus, minus, plus, minus, plus, minus, plus. The original equation, the inequality was, okay, I'm gonna write it here. So we want to find the range where this function, this ratio is less than 0. So I want this, and this one. So putting all together, the final result is x and this is this one, less better to do this thing. This one, I will draw it in green, and this here I have the equal sign. So this is the second solution. And I have a third solution given by this range. And I have also an equal sign here. So these are the solutions of the inequalities. Let's make the last exercise. The last one is a system of inequalities. Okay, so from the first one, I can place again t equals to sine of x, and I get this system. So 2t squared minus 1 greater than or equal to 0. And I will report the second one. From the first one again, I get t squared greater than or equal to 1/2, and again t from the first one. Okay, so considering the substitution we did before, I write that sine of x I replace t with sine of x, and I will write here the equation. Okay, so we have already solved each inequality independently, so I will report only the result. From the first one, I get this. These are all results that we already found before, so I'm going fast on this. And now, to put all together, I have to draw again a graph when I'm going to report all the solutions. So I'm going to draw a line here, and I will report all the solutions I found. Now I'm going to report for the first one and the second one solutions. So from the first one I get this range, this interval. As before, the point is an equal sign, and the empty circle is where I don't have an equal sign. Here I have an empty circle. Okay. From this graph, I can say that the result of the system is where I get an intersection between the first line and the second line. So these are the ranges where the system is satisfied. To put all together, so this is the solution of the system of inequalities. Okay, so I finished the lesson, finishes here.